Abhinav, come this side. You also sit here, Abhinav. మల్లేష్ గారు ఓం నమ శివాయ, ఓం నమ శివాయ. లైవ్కి రండి మల్లేష్ గారు. మీరు సండే రోజు లైవ్ ఉంటుంది. ఎవ్రీడే మాట్లాడడానికి కుదరట్లేదు బికాజ్ క్లాస్ రన్ అవుతుంటుంది కదా, అందుకని. సో డెఫినెట్గా సండే లైవ్ మన సబ్స్క్రైబర్స్ కోసమే పెడుతున్నాను. సో డెఫినెట్గా 7 to 8 లైవ్ మాట్లాడుకుందాము. డెఫినెట్గా 7 to 8 సండే. ఓకే మల్లేష్ గారు, క్లాస్ టైం అవుతుంది. ఓం నమ శివాయ. ఓం నాట్ మార్నింగ్, ఈవినింగ్ సండే ఈవినింగ్ 7 to 8. ఓం అరుణాచల శివ. ఇటు వచ్చి కూర్చో. ఇటు జరగమ్మా అభినా, ఇటు జరుగు, నువ్వు ఇటు జరుగు. Refraction. Light seems to travel along straight line path in a transparent medium. If you take a glass, it is a transparent. We can see other side also. Okay, which you are able to see the things other side also. That is called transparent. Some clothes also very transparent, right? So like that, even light travels through that transparent objects, right? What happens when light enters from one transparent medium to another transparent medium? What will happen? Will anything happen? Light travels, we can see the thing. If there is, suppose imagine this is the transparent object. Suppose if light is entering from one medium to another medium, what is that medium called? Medium means this is air, this side. Once it enter into this paper, is it air? Is it gas? No. It is a solid. Right? It is a solid. Imagine this is the glass. Okay, this is the glass. One plain mirror you take. Okay. Sometimes nowadays many buildings are constructing windows are outside, we can see, inside people we cannot see, right? Outside people. How are we able to see that people outside? obviously. Okay. If it go through it, will anything to happen to light rays? That topic we are going to discuss. Okay, one medium to another medium. If light travels, if light rays travels, what will happen? This is our topic today. Okay. So does it still move along a straight line path or change its direction? Suppose this is the transparent glass. This is the transparent glass. Okay. Suppose if light rays are falling on this, will this light rays travel in straight direction or it will change its directions? That is my question. Will it go straight as before? It will change its direction. Your answer is it changes its direction. Before straight light rays travel in a straight, okay, straight. Once if it enter into other medium, I am not saying it is only gas or solid or liquid, any other medium. Before it was other medium, it is air. Imagine air. Once if it travels through other medium, will the direction of the light changes? Will the direction of the light changes? Will the direction of the light changes or not? It changes. We shall recall some of our day-to-day experiences. You might have observed that the bottom of a tank or a pond containing water appears to be raised. Okay. Suppose if you see one tank, okay, water which is there at the bottom will appear as it is right. It will appear. The actual water is here only. Have you observed like that? Very low only, in the bottom only. But it appears to be very high level. Water is at high level. Even in the rivers. Okay. Similarly, when a thick glass slab is placed over some printed matter, the letters appear raised when viewed through the glass slab. Have you observed this one? You might have observed. If you see the, what do we call them? Abhinav is sleeping. Abhinav is not listening my class. Go and wash your face, Abhinav. from the portion of the pencil inside water seems to come from a different direction compared to the part above water. Here, if you consider all these cases, the case of the apparent displacement of a pencil partly immersed in water, the light reaching you from the portion of the pencil inside water seems to come from a different direction compared to the part above water. The light reaching you from the portion of the pencil inside. Suppose if you immerse water pencil in a water tumbler, okay. Now I am using a pencil here. This is the pencil. I immersed it, not full, partially. Not full. Okay. Now we are viewing from here. Okay. You are viewing the pencil from here. Okay. So light reaching you from the portion of the pencil inside water seems to come from a different direction compared to the part above water. This makes the pencil appear to be displaced at the interface. For similar reasons, the letter appear to be raised when seen through a glass slab placed over it. Whatever the light is reaching, okay, whatever the light is reaching you from the portion of the pencil inside, okay, here, this light is there now, here, okay, this light is reaching your eye. Then only you are able to see the letters which are there inside the water. Right? How you are able to see? After reflection only you are able to see the things. How are you able to see the letters? Because light rays enter here. This after incident rays that will reflect to your eye. That is why you are able to see the object. This is concept of reflection. How are we able to see the things? Light, incident rays fall on any object. That incident rays again will reflect on our eye. Then that is why we are able to see the things. Okay. Here, whatever the light is there here, after reflection it is reaching to your eye. Reaching to your eye. That is what they are saying here. The light reaching you from the portion of the pencil inside water seems to come from a different direction. They are coming from a different direction. Okay. Compared to the part above water. Compared to the water above water here. Whatever here light is there, these are appearing small only. But inside they are appearing bigger because this medium direction is different. Above there is no medium, air only is there. But inside there is another medium, liquid is there. That time it is changing its direction. Right? Are you like kerosene or turpentine. Turpentine we use for the paints, liquid-like substance. It is also liquid. Okay, if you take the kerosene or turpentine instead of water, will it be same like that only? Direction of the light. That is also liquid, no? Water is liquid, turpentine is liquid, kerosene is liquid. How the light direction changes? Is light the direction changes or not? While the letters appear to rise to the same height, if we replace a glass slab with a transparent plastic slab, if you take a glass slab, once do this experiment, and you take the plastic slab, do the same experiment. Will the letters appear in the same height as we have seen before? You are changing the substance here. You are changing. You are changing. You will find that extent of effect is different for different pair of medium. These observations indicate that light does not travel in the same direction in all media. If you change the medium, light directions also changes. This is only point we are conveying here from the whole paragraph. If you change the medium, light directions also changes. Light directions also changes. If it is in the case of plastic slab, one direction, one angle. Okay. Law of reflection follows in all the medium. Law of reflection. What is the law of reflection? If the light rays falls 90 degrees, even incident ray falls 90 degrees, again reflected ray also come back with the 90 degrees only. Incident ray is equal to the reflected ray. Angle of incident ray is equal to the angle of the reflected rays. Okay. Law of reflections will not change. But when you change the medium, direction will changes. Direction will changes. It is not same in all the mediums. So same direction light will not follow. Direction of the light is not the same in all the medium. That is what I wanted to convey. Are you clear with this? What do you understand? Different mediums. Light direction changes. Different light directions. That's it. Okay. So it appears that when traveling obliquely from the one medium to the another medium, the direction of propagation of light in the second medium changes. When it is traveling obliquely from one medium to the another medium, the propagation changes to the second. This phenomenon is called the refraction of light. Okay. If it falls light obliquely, okay, if it appears that when traveling of obliquely one medium to the other, this is air medium, okay, this is glass slab. Imagine this is the glass slab. This is another medium. This light is obliquely entering into the one medium to another medium. What is that another medium? This is glass slab, solid. Here it is gas. Here it is solid. One medium to the another medium. Okay. It appears that when it is traveling obliquely from one medium to the another medium, the The propagation of light is changing. Propagation of light is changing. When it is entering from one medium to the another medium. Propagation of light is changing. Propagation is when it obliquely enters from one medium to the another medium. Light propagation changes. Light propagation changes. That is called a law of light, the refraction of light. That is called refraction of light. What is refraction of light? Light traveling from one medium to the another medium. Light propagation changes. Okay? That is called refraction. That changing propagation of light is there, that is called refraction. It is not going in the same direction. Same propagation, it is not going right. It is changing. That change is there, that is, we are calling it as refraction. Suppose slightly, if this is going like this direction will change. This propagation of light is in this way. After entering into another medium, it is going like this. This change is there now. It should be like this, but this is going like this. The propagation of light is in this way. So this change is there now. That is called a refraction. Did you get my point? So next. This phenomenon is known as refraction of light. Just to go through the activity 10.7. 10.7, you read it. Place a coin at the bottom of the bucket and filled with water. Okay, I think you might have observed this experiment many times. If you place the coin inside any tub, will it appear in the same size? It will appear little bit bigger, right? So, with your eye to side above water, try to pick up the coin in one go. Did you succeed in picking up the coin? Will you place your hand where that coin is there? Otherwise, in other position you will keep it. Other position, right? We cannot pick immediately wherever that coin is. Then if you search like this, then you will pick up the coin. So, this is the repeat the activity. Why did you succeed in doing this? Go once again. Ask your friends to do this. Compare your experience with their others. Next one. Place a large shadow bowl. Shadow bowl. Bowl is there. Then shadow. Okay. Shallow bowl, yes, on a table, and put a coin in it. Shallow bowl means move away slowly from the bowl. Stop when the coin just disappears from your sight. Ask a friend to pour water gently into the bowl without disturbing the coin. Keep looking for the coin from your position. Does the coin becomes visible again from your position? No. Yes. If you actually with our eyes we cannot see, it is away from your eyesight. Okay. Even though you can see the coin, that it will appear that coin will reflect in other position actually. What they are saying, keep looking for the coin from your position. Does the coin become visible again from your position? How could this happen? The coin becomes visible again on pouring water into the bowl. The coin appears slightly raised above its actual position due to the refraction of light. after pouring water also, that the coin it seems to be raised little bit. That is why you are able to see that coin. This is because of the refraction of light. Okay. First of all, Amma, if we want to see any object, suppose I am able to see this object, how am I able to see this object? Light rays are falling here. Then this light rays again after reflection they are coming into my eye. That is why I am able to see this textbook and letters everything. If light only is not there, if it is in the dark, that is why we are not able to see. In the dark, why we are not able to see? Light incident rays are not there, then reflection rays will not be there. That is why we are not able to see the any object in the dark. Okay, that is reflection. Now here refraction means whatever this light rays are falling, that medium is changing. Medium is changing. That is why when the medium changes, light propagation changes. Light propagation changes. Light propagation is changing. That is why we are able to see the things bigger in size. Bigger in size. We are able to see the things bigger in size. Okay. This is due to the refraction of light. Refraction. Okay. There is a bigger difference in reflection and refraction. Okay. So, next if you see, activity 10.9, draw a thick straight line in ink over a sheet of white paper placed on a table. Okay. Place a glass slab over the line in which way that one of its edges make an angle with the line. Look at the portion of the line under the slab from the sides. What do you observe? Does the line under the glass slab appear to be the bent at the edges? Next, place a glass slab such that it is normal to the line. Okay. What do you observe? Does the part of the line under the glass slab appear bent? Look at the line from the top of the glass slab. Does the part of the line beneath the slab appear to be raised? Why does it happen? You are changing the angles. You have drawn a line on the white sheet, you placed a glass slab on it, and you are viewing that line from upper, from side. You are seeing how this line is appearing. Whether it is becoming bigger or smaller. Once you observe it, you can do this one. Glass slab you can take, you can draw the line, you can view from up, you can view from the side. Okay. Will it appear in the same size or in the bigger in size or in the smaller in size? So, now we will study the glass slab only. Rectangular glass slab. Suppose rectangular. Okay, there is a rectangular glass slab is there. Rectangular means two sides are equal in size, right? Okay. Like this one glass slab is there with me. Okay. How this light travels from that rectangular glass slab? How this light propagation will happen? That is only the refraction, right? Refraction. What is the refraction in the case of rectangular glass slabs? Okay. To understand this phenomena, let's do an activity. Go through the first activity. This is fix a sheet of white sheet on a drawing board. Fix a sheet of white paper on a drawing board using drawing pins. is the glass slab. Okay. This one you place down. There is white sheet. One cardboard is there. Okay. Cardboard is there. On that cardboard you place one white sheet sheet of paper. On that you place the glass slab. This one. Okay. Draw the outline of the slab with the pencil. Yes, I have drawn the outline. Okay. With the pencil I have drawn. Let us name outline as A, B, C, D. This is A, this is B, this is C, this is D. Okay. Take 4 identical pins. Same pins you take. Fix 2 pins, say E and F. Here light rays are coming. Actually, I have drawn bigger in size. I will take smaller. Rectangular slab, no? I will take 2 sides equal, then like this, okay? A, B, C, D. Okay. Now fix 2 pins, say E and F. Here, E and F. This pins I fixed it on the cardboard. Imagine, okay? E and F. Vertically, such that the line joined into the 2 pins inclined to the AB. Inclined. Vertically, not straight. Not like this. I have not placed the pins straight. Vertically, vertically I have placed. Okay. So, look for the images of the pins E and F to the opposite edge. Fix 2 other pins, say G and H. G and H. Same. This should come like this actually. Okay, these pins should appear. This is the glass slab, no? It is like this. On the board it is appearing like this. But this is glass slab. Here 2 pins. This image where it will appear here only. That 2 are drawing here. Actually, it should be, if it is vertical means, it should appear like here. Here it should appear. But these are appearing little bit vertically means like this, no? Vertically. Straight means like this. Vertically means like this. Vertically these are placed like this. Vertically means same, it should go straight means like this. Here it should place. But little bit this side, that image is appearing. This side, slightly. Okay. Not here. Here it should appear actually. But they are not appearing here. They are slightly appearing a little bit this side. Okay. Just these pins are G and H. G and H. Remove the pins such that these pins are the images of the E and F lie on the straight line. Remove the pins and flap. Join the positions of the tip of the pins E and F and produce the line AB. E, F meet AB to O. Okay. O dash. Similarly, join the positions of the pins of the pin G and H produces CD. Let us meet at O dash. In this activity, you will note that the light ray has changed its direction at point O and O dash. Surfaces separating to 2 transparent medium. Draw a perpendicular N and dash. Join these 2 up. Okay. And this you place line on the slab also. And join these 2 pins also. This whatever Why? Because there is a medium. Another medium is there. What is that another medium? Glass slab is there. That is why that refraction, changing its propagation of light happen. Okay. Note that the both points O and O dash lie on the surface of the separating two transparent media. Okay. Draw a perpendicular N dash to A, B, O and another perpendicular N dash to C, B and O dash. The light ray at point O enter from a rarer medium to the denser medium. This is called, above whatever it is there, this is called rarer medium. This is denser medium. Glass slab is a denser medium. Light entered from the rarer medium to the denser medium. Right? That is from air to glass. Note that the light ray has bent towards the normal. Okay? At O dash, the light ray has entered medium to the rarer medium. The light here has bent away from the normal. Compare the angle of incidence with the angle of reflection of both refracting surfaces A, B and C, D. If you draw the perpendicular line N dash here, perpendicular line. Okay, this is N dash. Here M dash. Perpendicular line if you draw. Here compare angle of incident, whatever it is there. In the reflection, angle of incidence is equal to the angle of the reflection, right? Angle of the reflection. If you see here, compare these two angles. Okay, whatever this incident ray is there, after entering into the angular medium, what is the angle? Here also, here from denser medium to rarer medium. This is denser medium. Light is propagating in this medium. Again it is coming back denser medium. This is rarer medium. Okay. This is denser medium. Glass slab is a denser medium. Here from rarer, this is also rarer medium. From rarer medium to denser medium, this light is entering. Here, denser medium to the rarer medium, light is propagating. Compare the angles. Compare the angles. Angle of incident and angle of the refraction. Are the both angles the same? No. Because medium incident ray. After entering into the glass slab, the path of the light, whatever it is there, it is called a refracted ray. You may observe that the emergent ray is parallel to the O dash is the refracted, O dash H is the emergent ray. This is O dash. This is emergent H. G is there. Okay. This is there, na? This ray. This is emergent ray. Emergent. Are you clear with this rays? This is incident ray falling. After entering into the glass slab, this is refracted ray. Once coming from glass slab to outside, okay, images are forming as distinct images. From here till here, whatever this ray is there, this is called emergent ray. Emergent ray. You may observe that the emergent ray is parallel to the direction of the incident ray. It is parallel to the direction of the incident. Why does it happen so? This is, if you see this one, this ray, it is parallel. Parallel this ray is there. Why it is like that? Because of the refraction. Because of the refraction. The extent of bending of the ray of light is opposite parallel faces AB and CD of the rectangular glass slab is equal and opposite. This is why the ray emerges parallel to the incident ray. However, the light ray is shifted sidewards slightly. What happens when the light ray is incident normally to the interface of the medium? Now you are familiar with the refraction of light. Refraction is due to the change in the speed of the light as it enters from one transparent medium to the another transparent medium. Experiments show that the refraction of light occurs according to the certain laws. Okay, why this propagation of light is changing means here speed is changing. Okay, in rarer medium, light speed is high. When it is coming to the denser medium, light travels with low speed. Okay, so that is why this refraction is occurring. I think you are clear with the refraction. Are you clear with the term refraction? Abhinav? Refraction, I think clear that. Definition is nothing. Here definition means it is changing its direction. Propagation of light changing. Okay. ఇలా ఉంటే ఇలా రావాలి. అలా రాకుండా సైడ్కి వస్తుంది. రిఫ్రాక్ట్ అవుతుంది. ఎందుకు? Because mediums are changing. Because mediums are changing. Light travels with different speed. రేరర్ మీడియంలో ఒక టైప్ స్పీడ్ ఉంటుంది లైట్కి, డెన్సర్ మీడియంలో ఇంకొక టైప్. అందుకని రిఫ్రాక్షన్ అనేది జరుగుతుంది. అదే డైరెక్షన్లో కాకుండా మనకి డైరెక్షన్ అనేది చేంజ్ అవుతుంది. రైట్ ద డెఫినేషన్ ఆఫ్ ది రిఫ్రాక్షన్ ఆఫ్ లైట్. రైట్ ద డెఫినేషన్. When the light traveling, write an Abhinav definition. When the light traveling obliquely from one medium to another, the direction of propagation of light in the second medium changes. This phenomenon is known as refraction of light. Next point you write. Refraction is due to change in the speed of light as it enters from one transparent medium to another. Yes. First one is it follows some refraction laws. I told you, no? Okay, it follows some refraction laws. What are the refraction? The incident ray, the refracted ray, and the normal ray. The interface of two transparent medium at one point, incident, all lie in the same plane. What are they are lying same plane means? One is the incident ray. Okay, who are lying in the same plane? Incident ray, refracted ray, and normal to the interface of two transparent medium at the point of incidence. Okay, this one, whatever it is there, this one, again this one, all they lie in the same plane. This is first law. Okay. Second one, the ratio of the sine of the angle of incidence to the sine of the angle of the reflection is a constant for the light of the given color and for a given pair of medium. This law is the Snell's law of refraction. Very important amount. From the refraction, Snell's law. Write down heading. Wait, first, laws of reflection heading. You keep laws of reflection. Refraction. Laws of refraction. First one you keep the incident ray. The incident ray, comma, the refracted ray. And the normal to the interface of two transparent media at the point of incidence. Two transparent means TWO, not TO. TWO, two transparent media. Okay. All lie in the same plane. This is first law. All lie in the same LLS. Snell's law. Very important. Definitely you will get in the exam. Okay, very most important. Snell's law. Snell's law. The ratio of the sine of an angle of incident. Okay. The ratio of the sine, S-I-N-E. The ratio of sine of angle of incidence to the sine of angle of refraction. To the sine of angle of refraction. See here. The ratio. See here, look at me. The ratio of the. This is ratio now. Okay. The ratio of the sine of the angle of incidence. Sine of the angle of incidence to the angle of refraction. It is a constant. It is constant. Okay. This is Snell's law. Of what? For the light of the given color and for the given pair of medium. This law is known as the Snell's law. Okay. This is true for the 90 degrees. Write down this one down. Whatever this constant value is there now, this is called a refractive index. This is refractive index. Refractive index. Refractive index. That will have certain values for one medium. This refractive index values will be there. Till where did you write Snell's law? The ratio of sine of angle of incidence, sine of angle of incidence, the sine of angle of incidence to the sine of angle of refraction, to the sine of angle of refraction is a constant. Is a constant. For the light of a given color, for the light of a given color and for the given pair of media, and for the given pair of a media. This is known as Snell's law of refraction. This is known as Snell's law of refraction. Okay. Tomorrow we will continue with the refractive index. This constant value is there now. We will study about the refractive index. This is very important table, okay, which is there. On this only you are going to get the problems actually based on this. We have seen today refraction through the rectangular glass slab. Rectangular, very important class, Amma. Okay, you will get problems from this also. One is from which we discussed yesterday problems. Size, nature, position, everything they will ask. Again, next one, the question we will get is here only. doubts ఉన్నాయా ఫస్ట్ చాప్టర్ ఏమైనా డౌట్స్ ఉంటే matter is made up of particles. If you take suppose what do we say నీటి వేసుకుంటాం కదా మనం వైట్ షర్ట్స్ లేదు అంటే నార్మల్ మనము ఫ్లోర్ క్లీనర్ తీసుకుంటాము ఫ్లోర్ క్లీనర్ సపోజ్ ఒక గ్లాస్ తీసుకుంటాము జస్ట్ ఒక చిన్న కప్ దాంట్లో నుంచి ఒక చిన్న కప్ కొని వేసిన తర్వాత మళ్ళీ ఒక చిన్న పెద్ద సైజ్ దాంట్లో కూడా వస్తుంది ఆ ఫ్లేవర్ మళ్ళీ ఆ దాంట్లో నుంచి ఇంకొక దాంట్లో తీసుకోండి ఒక పెద్ద టబ్లెట్ తీసుకోండి దాంట్లోకి వస్తుంది అమ్మ ఫ్లేవర్ తీసుకొని వేసేదేమో ఇంత కప్పు ఫస్ట్ దాంట్లో స్ప్రెడ్ అయింది సెకండ్ దాంట్లోకి వచ్చింది మళ్ళీ థర్డ్ దాంట్లో ఇంకొంచెం పెద్ద టబ్లో తీసుకొని వేయండి మళ్ళీ ఆ పార్టికల్స్ అన్నీ కూడా ఇంకో దాంట్లోకి వస్తుంది సపోజ్ ఇంకొక పెద్ద ప్యాకెట్ వేయండి ఆ దాంట్లో నుంచి తీసుకొని ఒక చిన్న కప్పు తీసుకొని మళ్ళీ థర్డ్ నుంచి దాంట్లోకి వేస్తే మళ్ళీ దాంట్లో కూడా ఉంటాయి ఏవి ఏ పార్టికల్స్ ఫ్లోర్ క్లీనర్ యొక్క పార్టికల్స్ అనేవి ఉంటాయి కదా పార్టికల్స్ అంటే ఏదైనా ఒక మ్యాటర్ అనేది పార్టికల్స్తో ఉంటుంది అనమాట ఇట్ ఈస్ మేడప్ ఆఫ్ పార్టికల్స్ ఇట్ ఈస్ మేడప్ ఆఫ్ particles for a long time. If you see in order to answer this, you need the idea for the matter is made up of particles. See what are they taken here? In that they added what? Salt. Okay. You stir that one, it will become salt water, right? So this salt particles spread throughout the water. Salt particles spread throughout the water. They are very small. They are very small. We cannot see with our naked eyes. Once it is dissolved, salt we can see when it is solid. After dissolving the water, they cannot see that particles. It is, you remember from this, matter is made up of particles. Yes. It is kilogram. The SI unit is kilogram. How will you buy salt? Kg. Okay. That is only SI unit is kg. SI unit of volume is cubic meters. Cubic meters, the common unit for measuring the volume is liters. First year 1 liter equals to 1 cubic decimeter. Usually, for solids we use kg, right? Measuring unit. For liquids, liters. 1 liter equals to 1 cubic decimeter. 1 liter equals to 1 cubic decimeter. How kilogram is divided into grams? Like that, decimeters. This liters is divided into decimeters. One kilogram equals to 1000 grams, right? 1000 grams. Like that, 1 liter is equal to 1 cubic decimeter. 1 cubic decimeter. These are the measuring units. Okay. 1 liter equals to how many ml? 1000 ml. 1000 ml. 1 liter equals to 1000 ml. 1 ml equals to 1 ml equals to 1 cubic centimeter. It will help in the it is there already in the text. Down. Okay. 1 milliliter equals to 1 cubic centimeter. Which we use the SI unit for liquids. 1 liter equals to how many ml? 1000 ml. Okay. Nothing. Any matter is there. Suppose salt is there. It is made up of particles. That is what I explained. They have taken example of Dettol. I have taken the example of floor cleaner. Once when your exams are going on, you will revise that topics once again. If you don't understand any concept, I will do that. What is solution? I already told you that. It is a homogeneous mixture of two or more substances. Homo means this one. Homo means same. Homo means same. Okay. Homogeneous. It will have two or more substances. Pure substances. A solution is a homogeneous mixture of two or more substances. Suppose if you add water to the water, if you add salt, that both will mix. It is a mixture of salt and water. It is a mixture of salt and water. If you take alcohol and water, if you mix that both alcohol and water, okay, both are liquids. It is a homogeneous mixture. Same type of substances. Homogeneous. You come across various types of solutions in your daily life. Lemonade, soda water, these are all examples of solutions. Lemonade, soda water, sugar water, salt, all these are usually think solution as a liquid that contains either a solid, liquid or a gas dissolved. But we can also have solid solutions and gaseous solutions. In a solution there is a homogeneous particle level. For example, lemonade tastes the same throughout. This shows the particles of sugar or salt are evenly distributed in the solution. If you take salt solution or sugar solution or lemonade means lemon you squeeze in the water, it will become lemonade. Okay. If you take that water, it will not be like some is very salted water, other is not tasted water. No. Throughout that it will eventually mix in the water. Okay. Give the same taste. So, what are alloys? Are you aware of alloys? Alloys are the mixtures of two or more metals, or a metal and a non-metal, and they cannot be separated into their components by physical methods. If you see the gold, then you take from the minerals, gold is mixed with other metals also. Copper also it is mixed. Right? We need to separate that copper. If you take minerals from the earth, they are not pure substances. They are mixtures. There are many other metals are mixed with that gold. So we need to do some methods and we need to separate that. Chemical methods we should use. With physical methods, with the hand we cannot separate. In the rice, if you have any stones, you can separate with your hand. But when it is gold mixed with other metals, how can you separate that metal? It is difficult, right? You have to use some chemical methods. Physically, we cannot separate those metals. Those are called alloys. They are the two or the more. Alloys are mixtures of two or more metals, or a metal or a non-metal. It can be both metals or non-metals also. Okay. Elements are three types: metal, metalloid, metals, non-metals, metalloids. Okay. All elements entire periodic table have divided into three: metals, non-metals, metalloids. Okay. This alloys may be mixture of metals and non-metals also. It is a mixture of two or more substances. Okay. approximately 30% zinc, 70% copper. Bronze metals we use in the household purpose also. Okay, 30% is zinc is there, 70% copper is there in the bronze. Okay, it is also alloy. Bronze is a alloy. It is a mixture of two metals. Okay, zinc and copper. Zinc and copper. A solution has a solvent and solution as its components. The component of the solution that dissolves to the other component in it. Usually the component present in the larger amount. It is called solvent. The component of the solution that is dissolved in solvent usually present in lesser quantity, that is called a solution. If you take the sugar solution, Amma, I have taken okay, one glass. I have taken water. I am adding tablespoon of sugar. Okay, I am adding in it. Okay. So after adding, if I split this one, that will become solution. Okay. There are two components in the solution. This is called a solution. Solution. The component which is present in lesser quantity, the component which is present in smaller quantities, that is called solute. Solute. Okay, solute. S-O-L-U-T. Solute. The component which is present in larger quantity, that is called water. In the sugar solution, who is solute, who is solvent? Very good. Solute is sugar, solvent is water. Because larger quantity is water. Okay. Iodine in alcohol, it is a tincture of iodine. You know tincture of iodine we use when we have the wounds. We apply tincture. No? Tincture, that is a solution of iodine in alcohol. It is a solution of iodine in alcohol. Okay. Iodine is a solid. Okay. And alcohol is a liquid. Iodine we add a little bit in the alcohol. So here iodine is the solute, alcohol is the solvent. And aerated drinks like soda water. Soda water is there. Gas is a liquid solution. This contains carbon dioxide solution. In the soda water, what gas they emerge into the liquid? Carbon dioxide. Carbon dioxide. In the soda water, carbon dioxide is a solute. Water is a solvent. Okay. Air is mixture of gas. Air is a homogeneous mixture of number of gases. Two main consist of oxygen 21%, nitrogen 78%. If you see in the air, there are many gases present in the air. Two main gases, if you consider oxygen and nitrogen. Oxygen is present 21%. Nitrogen is present 78%. But we are not able to separate those gases. It is a homogeneous mixture. Okay. The other gases also present in the smaller quantities, 0 points. They are present. So if you come across the properties of solution, it is a homogeneous mixture. Solution is a homo means same, hetero means different. Okay. The particles of the solution smaller than 1 nanometer in diameter. So they cannot be seen with our naked eyes. Can you see the sugar particles in the sugar solution? Because they are very small, very tiny. Okay, they are measured in nanometers. Nanometers. We cannot see with our naked eyes. Cannot see with our naked eyes. Why? Because they are very smaller in size. Okay. Because of very small particle in size, they don't scatter a beam of light passing through a solution. So the path of the light is not visible in a solution. Because these particles are very small. Okay. Light cannot pass through this solution, beam of light. It is not scattered actually. It is not scattered. They do not scatter a beam of light passing through the solution. The path of light is not visible. Okay. We cannot see the path of the light through this solution. Why? Because they cannot scatter the light. They cannot scatter the light. As they are in very small in size. Particles are very small in size. The solute particles cannot be separated from the mixture of the process of filtration. The solute particles do not settle down when left undisturbed. That is, the solution is stable. Solution, can you filter the sugar after mixing with water? Salt solution. Tincture, can you separate the iodine? By filtration. If you make tea or coffee at home, you can filter out the coffee powder or tea powder out. Because particle size are bigger. Okay. But here, is it tea or coffee? Before filtration, is it a solution of homogeneous? Coffee powder with water, sugar. Is it a homogeneous? No, heterogeneous. Both can separate it by filtration. Coffee powder or tea powder, we can separate it. Right? So, solution is a stable. Solution is a stable. These are the some properties of solution. Say the properties of solution and this one. What is the solution? Here is the from here to here you read. If you don't understand anything, ask me. చెప్పండి ఇప్పుడు చెప్పండమ్మా సండే రాయండి ఏది రావట్లేదు చెప్పు తీసుకురా ఒకసారి This is the ratio of sine of angle of incidence. Incidence here. Sine of angle of incidence to the sine of the angle of refraction is a constant. The formula will describe this. The formula words lo rasaru. Okay, it is the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. For a light of given color, given a particular coloration here, and for the given pair of the medium, a pair of medium, ఈ వాల్యూ అనేది కాన్స్టెంట్గా ఉంటుంది. పెట్టుబడి తగ్గుతుంది. దానికి ఎయిర్లో ఎలా ఉంటుంది, ఐస్లో ఎలా ఉంటుంది, వాటర్లో ఎలా ఉంటుంది, ఈ రిఫ్రాక్టివ్ ఇండెక్స్ కూడా కాన్స్టెంట్ ఉంటాయి. ఈ వాల్యూస్ ఆ వాల్యూస్ కూడా ఇచ్చవచ్చు. ఎలా పట్టాలి అప్పుడు టర్పెంటైన్, ఆయిల్, బెంజీన్, క్రోమ్, గ్లాస్లో ఎలా ఉంటుంది అంటే వాల్యూస్ తెలుస్తుంది. బాల్సమ్, రాక్ సాల్ట్, ఇవన్నింటిలో for a given pair of కాన్స్టాంట్ వాల్యూ తీసుకోండి. రిఫ్రాక్టివ్ ఇండెక్స్ ఆ కాన్స్టాంట్ వాల్యూ ఏదైతే ఉందో ఆ మీడియంస్కి, ఆ కలర్స్కి, పర్టికులర్ మీడియం కలర్స్కి దాన్ని మనం రిఫ్రాక్టివ్ ఇండెక్స్ అని ఇస్తాం. This is true for angle 0 is greater than incident. Incident ray is greater than 90 degrees. I is angle of incidence. I is angle of incidence. R is angle of refraction. I ఎక్కడ కనిపించినా కూడా angle of incidence అని చదువు. 0 is greater than the angle of the incidence. Angle of incidence is lesser than the 90 degrees. 0 is lesser than the, that means who is greater than angle of incidence is greater. Okay, here angle of incidence is lesser than the 90 degrees. The ratio of sine of angle of incidence to the sine of angle of refraction is constant for the given color and for the given pair of medium. This is Nelson. Angle of I and M angle of incidence, angle of incidence, sine of, sine is the ratio of sine of angle of incidence incidence to the sine of angle of refraction is constant. The ratio by unta ratio ane chadutadu. The ratio of for a given pair of color, for a given pair of medium. Okay, this law is known as Nelson. It is Nelson. It is refraction of light law. This is another law, this is another. The first law is the incident ray, the refracted ray, normal ray. ఇవన్నీ కూడా ఒకటే ప్లేన్ మీద ఉంటాయి అని చెప్తాను. ఒకటే లైన్, ఒక లైన్ గీసాము, ఇవన్నీ కూడా ఒకటే లైన్ మీద ఉంటాయి. ఒక పర్టికులర్ లైన్ గీస్తే అన్నీ కూడా ఒకటే లైన్ మీద వస్తాయి. దే లై ఆన్ ద సేమ్ ప్లేన్. The incident ray, refracted ray, normal to the interface of two transparent medium. Two transparent medium. At the point of incidence. ఎక్కడంట అంటే ఇప్పుడు మనకి ఇది పడుతుంది రే ఇక్కడ పడుతుంది కదా, ఇది ఒక మీడియం, ఇది ఒక మీడియం, ఇక్కడ పడుతుంది ఇన్సిడెన్స్. At the point of incidence, all lie in the same plane. The solute particles cannot be separated from the mixture by the process of filtration. అదే చెప్పాను కదా ఫిల్ట్రేషన్. ఫిల్ట్రేషన్ మామూలు కాఫీ పౌడర్ని ఫిల్టర్ చేస్తాం కదా మనం. ఫిల్టర్ ఉంటుంది, సపరేట్ చేయడానికి ఫిల్ట్రేషన్ అంటారు. చెప్పండి.
Laws of refraction of light. First law, the incident ray, the refracted ray and the normal to the interface of the two transparent media at the point of incidence all lie in the same